All right, this lesson is going to be on transformations. And before we talk about transformations, we do need to talk about the parent functions. And I took this out of the book, and it's really small and kind of hard to read. So I'm going to rewrite the equations for you in case you can't see them. But a constant function is going to be a horizontal line. And this equation that you can't really see well is f of x equals c. So any constant number.
Can I have your attention, please?
All right, the next one is the identity function or the linear parent function. And so it's a line that goes through 0, 0 that has a slope of 1, and the equation for it is f of x equals x. Right. We have an absolute value function, which is going to be in the shape of a v, and the equation for it is f of x equals the absolute value of x. Right. And then this is the square root function, and you can see its shape. It's kind of like it is half of a parabola on its side, but its equation is f of x equals the square root of x. Right. And then we have the quadratic equation. The graph is a parabola. It's f of x equals x squared. The cubic one you may not be super familiar with, but this is the shape of the cubic, and the equation is f of x equals x cubed. Right. And the reciprocal function is another one you may not be super familiar with, but its equation is f of x equals 1 over x. So every number you put into it, the y value is going to be the reciprocal of that number. And then the greatest integer function is a new one we talked about a couple weeks ago, and the symbol for it is that double brace. All right, so what all the parent functions have in common is there's no addition, subtraction, or multiplication. It's just one thing that's happening. So just the absolute value, just the x squared. That is what a parent function is going to be. Like, there's not going to be any addition, subtraction, or multiplication or negatives. So what happens with those additions, subtractions, multiplications, negatives, is they transform these graphs to look a little different. And so we're going to go through all the transformations today. All right, so one transformation is whenever you take a function, a parent function, and you shift it up. So to shift a parent function up, you add outside. So that would be something like y equals x squared plus 2. That would take this parent function and shift it to up to get a new function, a transformed function. Right. Another shift is a vertical shift down, and that happens whenever you subtract on the outside. Right, so that would be something like y equals x squared minus 3. I would take the quadratic graph and shift it down 3 units. All right, then we have horizontal changes. Horizontal shifts happen on the inside, and what I like to tell my students to kind of help them remember this is that the inside lies. So anytime it's horizontal changing, it happens on the inside, and the inside is going to be the opposite of what you think it would be. Right, so if I'm going to take a function, I'm going to shift it to the right, even though right is a positive direction, I'm going to actually subtract on the inside, because that is how it will shift to the right, because the inside lies. So an example of that would be y equals the absolute value of x minus 3. So that would take this absolute value graph and shift 3 units to the right. Right? A horizontal shift to the left is going to be kind of the opposite of what you would think it would be. You would add on the inside. So y equals the absolute value of x plus 4. We'll make it shift to the left. Okay, then we have some reflections. So to reflect a graph, you are multiplying by negatives. So if you want to reflect on the x-axis, that's going to be a negative on the outside. So for example, it would be like y equals the negative square root of x. That would take this square root function and reflect it on the x-axis, reflect it down to this side, the x-axis. All right, and then for the y-axis, that's going to be a negative inside. So for example, it'd be like y equals the square root of negative x. That would take the square root function and reflect it on the y-axis over this direction. And one thing a student of mine a long time ago, like she's grown and has a real job and everything now, but she said this and it kind of stuck with me, and I tell my students every year that when it reflects on the y-axis, she calls it the yin side. That just helps her remember y is the inside or the yin side. Okay, and then we have all the stretches and the shrinks. So a vertical change is always happening on the outside. So if we want a vertical stretch, you multiply by a number greater than 1 on the outside. Okay, so that would be like y equals 3 times the square root of x. That would make the graph of the square root of x be 3 times as tall. Okay, and then for a vertical shrink, you're still multiplying on the outside, but it's going to be a smaller number. So we're going to multiply by a number between 0 and 1 on the outside. Okay, so that could be something like y equals 1/3 square root of x. So that would take the square root function and it's going to shrink it to be a third as tall as the original. All right, and then these horizontal shrinks and stretches happen on the inside, and I don't want you guys to forget that the inside lies. So it's going to be the opposite of what you want it to be. So on the inside, if you want to get a stretch horizontally, make it wider, then that number you're multiplying by needs to be a small number. And then if you want it to shrink horizontally, then that number you're multiplying by needs to be a larger number. So for the horizontal stretch, you're going to multiply by a number between 0 and 1 on the inside. So inside a small number is going to stretch. So that would be like y equals the square root of 0.5x. All right. And then to do a horizontal shrink, that needs to be a larger number, a number greater than 1. And that's on the inside. So y equals the square root of 2x. That's going to take the square root graph and it's going to horizontally shrink it. Okay, so we're going to do some problems. For example, 1, we're going to identify the parent function and describe the sequence of transformations from f to g. So the parent function is going to be f. The g or h function is going to be the transformed function, and we're going to describe the transformations. And this box up at the top, we're going to come back to that when we get kind of in the middle of the page. When we get to E, we'll come back to that one. Okay, so let's look at example 1. This is our transformed function. So the parent function is going to be one of these 8 functions. So the parent function for this one, since this is a cubic type of function, is going to be the cubic parent function. So I'm going to say f of x equals x cubed. All right, and then this one only has one transformation. We're subtracting on the outside, so that's going to be down 4. All right, then for the second one, the parent is going to be the quadratic function, f of x equals x squared. Right, and then this one has 2 transformations. So we are subtracting on the inside. So don't forget, subtracting on the inside is going to shift it to the right. So we're going to go right 3. And then we're adding on the outside. So that's going to be up 6. All right. We're going to go to C. So since this is a square root function, our parent function is just f of x equals the square root of x. Right? This one has a negative on the outside and a +2 on the inside. So let's start with the reflection. The negative on the outside is going to be reflection on the x-axis. And adding 2 on the inside is going to be left 2. All right, you guys try D on your own. All right, so E is one where it feels like this one is going to have a horizontal shrink, and then going to be shifted to the left 6. But that's actually not going to be the case. So I'm just going to grab a calculator real quick to show you. If we want to graph an absolute value, now we're not using the calculator very much in here, but the parent function is the absolute value of x. All right, and then this transformed function is negative, and then absolute value of 2x plus 6. Okay, so it does do, I didn't say the reflection, and it did shrink horizontally, but it didn't shift 6, it only shifted 3. So whenever there is a coefficient for your x inside and a horizontal shift inside, that shrink actually also shrinks the shift. It's hard to say. So this is where we have to do this box. So if x has a coefficient other than 1 and addition or subtraction inside the function, what we're going to do is factor out that coefficient. All right, so before we start figuring this one out, ones like this, I would go ahead. Now, you don't factor it out outside of the absolute value, just out of 2x and 6. You need to do that first. All right, then we can do our parent. F of x equals the absolute value of x. All right, and then you guys write down all the transformations. There's actually going to be 3 transformations. And we kind of already saw them, but... Okay, so we have the reflection on the x-axis because we have the negative outside. We have a horizontal shrink because we're multiplying by 2 inside. And then we're going to go left 3 because we're adding 3 inside. So just be careful on those. Remember that that horizontal shrink is also going to shrink a horizontal shift. Okay, so let's look at the parent. Oh, this one actually, we're going to have to do that also. So if we're looking at the coefficient of x here, the coefficient of x is -1. So I'm going to factor out that negative. So we factor the negative out of negative x is positive x. You factor the negative out of 4, it's -4. That didn't look too good. All right, so our parent is going to be the greatest integer function. All right, and then this one is going to have 3 transformations also. So we're multiplying by 2/3 on the outside. That's a vertical shrink. We have this negative on the inside, or the yin side. That's going to be reflection on the y. And then a -4 on the inside is going to be right 4. Okay, so you guys try to do G all on your own. You can pause it and then push play whenever you're done. All right, so those are the answers to that one. All right, and then for H, now the parent is going to be the square root of x. Now this coefficient is different than what we had on this one, because this one had a coefficient inside and addition or subtraction. This one doesn't, so we don't have to worry about factoring anything out. And these always kind of confuse people. Now this negative has nothing to do with the stretch or shrink. What is a negative inside gonna do? That's going to be a reflection on the y-axis. All right, and then the 1/2, we don't worry about the negative 1/2, we just look at the 1/2 when we're doing our stretch or shrink. Since it's on the inside, it's horizontal, and then the small number on the inside is going to be a horizontal stretch. Okay, we're going to do a couple of problems out of the book also. So on page 73, we're going to do number 47 and we're going to do number 57. So grab your book. Oh, sorry, 47 and 53. The directions on those say to write an equation for the function described by the given characteristics. So 47, the shape of f of x. It has the shape of f of x equals x squared, but shifted 3 units to the right and 7 units down. So we're not going to call it f of x. We can call it g of x. We can call it y. We can call it h of x. So we're going to call it something else. I'm going to call it g of x. It is a quadratic function that takes the parent function and shifts 3 units to the right. So 3 units to the right, we're going to subtract 3 on the inside. And then make sure that you square that on the outside. And then down 7 is going to be minus 7. All right, and then 53, this function we're going to write is in the shape of f of x equals the square root of x. So it's a square root function. It's shifted 6 units left, reflected on both axes. Okay, so let's call this one h. I know it's a square root, so I'm just going to go ahead and do a square root. So we're going to go we're going to go 6 units to the left. So I know I'm going to have an x plus 6. And then we reflect on the x-axis. So that's a negative on the outside. And reflect on the y-axis. So that's a negative on the inside. You guys think that's going to cut it? It isn't. So if I want to make sure that I really shift to the left like it says to, I'm going to have to put the x plus 6 in parentheses and the negative on the outside there. Otherwise, that negative will mess up my shift. All right, guys. So your assignment is on that same page we were just looking at. I want you to do 22 through 54 even. And on the directions, I want you to change them just a little bit. So I want you to do A and B only on 22 through 46 even. So don't do exactly what the directions say on those. There's extra stuff that you don't have to do.